So is it on? Great. Awesome. So that's fantastic. Well, thank you so much for the opportunity to present this work that I have had the privilege to build with an amazing team. This culminated in being my job market paper recently, and I'm very happy to share everything we have learned in 30 minutes. So as a motivation, think of your field in a subfield in economics or your field in social sciences. Focus only on the causal questions that can be answered in the literature that you know well, the field that you have studied and have deep expertise on. Each of these, each answer can be thought of an estimate to a question of the form of a difference between conditional expectations. The questions that I want to present is, first of all, can we observe all the questions that were in the original research? When you're reading your literature, can you observe everything? And of what we can observe, what fraction of the original questions, and what fraction of the, if we cannot observe it, what fraction of the original questions are never reported on? Okay? Those are the motivating questions. This is important because, A, there's a widespread belief that most of what we observe is statistically significant, and most of what we don't observe, it's sort of buried null results. And if this is true, it raises the likelihood of this sort of famous simulation result where most recent research findings are false. The bad questions for the field is that we cannot observe this dashed box. The good questions for a subset of empirical research in economics is that for randomized controlled trials, now the answer is yes. We can actually, in theory, we can observe the original set of questions or hypotheses, and we can start with this. We can start answering question number 2, and that's what we try to do in large part for this project. So for this project, I'm gonna we made 3 contributions. I'm gonna focus primarily on 2, but the first contribution is that we develop an approach to standardize and record hypotheses from the American Economic Association randomized RCT registry, where researchers record what's the research design, ideally before it's carried out. That would be called a pre-registration. So we develop an approach to standardize and record these hypotheses. And we also run our own randomized controlled trial on study authors to answer the following questions. The first question is, what fraction, this is the question that I showed at the beginning, what fraction of the pre-registered hypotheses have available results 8 to 9 years after? Do we see all the results 8 to 9 years after? Do we see a small fraction? What are we going to try to find? Conditional on what's available, what fraction of those results are null? That's going to be another question that we're going to answer here. And after that, we're going to try to uncover what are the constraints that prevent researchers from reporting on all of their original hypotheses. We're going to test different types of constraints in terms of lack of awareness, lack of engagement, or lack of resources. I'm going to give you more detail on that. But this is basically the contributions that we're trying to do, and at the same time, the outline of the presentation. So given the 30 minutes, I'm going to go very quickly over how we constructed our sample and our standardization approach. I love our standardization approach. I'm very happy to talk about it, but I'm not going to give you much details in this presentation. But in terms of building the sample, we took the universe of pre-registrations from the AEA registry from 2015 to 2017. We removed some exclusions, and that left us with a sample of 317 studies. And for each of these studies, for 317 studies, we did the following. We took each registration. The registration will be the green part here. The registration is for all intent and purposes, it's a free text. So we had to read it. and then we had to turn that free text into a rectangular data set per study, where we have a number of hypotheses per study, and then we go and look in the available literature, published papers, working papers, reports, dissertation, everything that we can find publicly available, how much of that is available 8 to 9 years after. Okay? This monumental work, primarily carried out by my amazing research assistants that are here today, led to a data set with 5,000 hypotheses. And these are main hypotheses. 3,700 are main hypotheses. 1,300 are main heterogeneity tests. And again, happy to talk more details, but for now I'm just going to ask you to believe me that we did a very thorough job at encoding these hypotheses. One thing that I'm not going to talk today here is that I'm going to emphasize that this is humans only. We basically very purposely said this stage one of our research agenda was to build this encoded data set only with humans, such that later on we can use it to explore how can we combine it with large language models. And that's sort of like the ongoing agenda right now, and it's not in this paper. So this is just good, hard labor. Okay. So what are the main outcomes that we are interested in studying? The first outcome is the fraction of hypotheses that are available per study. So here you have a study, has 4 hypotheses. In this example, 8 to 9 years after, we find 2. So the fraction will be a half, and then we're going to take the average of that fraction across all the studies in our sample. That's outcome number 1. Outcome number 2 is what fraction of these studies are null. For those that we can see, in this case, one result is null, the other one is not. And I'm going to, depending on whether or not I'm showing you the descriptive part of the study, I'm going to focus on conditional on availability, or if I'm showing you the results from the RCT, we're going to look at unconditional nulls. Finally, we added an exploratory outcome after we did our pre-registration, where while doing the process, it became pretty clear that there's something in between available and missing with unknown status. In between, there could be something that is missing, but we know why it's missing. So this would be a hypothesis that is not available, but we learn somehow while doing our intervention why why it was unavailable. Okay, those are going to be our three main outcomes, and I'm just going to jump right into our first main finding. We're going to characterize the file drawer for randomized controlled trials in economics. That's the first finding. This is our sample, 317 studies. What has done so far, and the Franco study has been mentioned several times, but this pioneer study, basically they look at the study level. What happened X years after? Was this study carried out? What's the significance of the study? But so doing something similar, we can do the same for this sample, and we see that 8 to 9 years after, 80% have a paper. This is a very similar estimate to what you can see in the Franco study. About 20% have nothing written up, and 80% have some type of report, right? But we can go beyond the study level, right? We can go at the hypothesis level. So we can say, for these that we have a paper, how many of them report their hypothesis, okay? So the first result is that 20% reports everything that they pre-register. About half reports something, and 12% have a registration, have a paper, but we cannot credibly link any result with a pre-registered hypothesis. That's the first result. But as I said, we did this for every study, so I can show you what happens for every study. And this is what we argue is a more accurate measure of the file drawer size in economics. Here, basically, you can think of each, there's a thin rectangle that represents each study, and here are the 317. These are the 20 that have everything. Those are the ones that have nothing. And here, this is the distribution of those that have something. if you take the average over all of that, we find that, on average, the fraction of pre-specified hypotheses with results is 42% across this sample. That means that this is like my favorite figure in the world, but I'm going to focus even in my favorite figure in my favorite panel. I want to emphasize that the first main finding of our study is that the file drawer measure in this more granular way reveals that the size of the file drawer is almost 3 times as large as you would think if you were measuring only at the study level. If you think at the study level, you think that 20% of studies are missing. If you look at the hypothesis level, it's about close to 60% of hypotheses are missing 8 to 9 years after. Finding number 1, okay? So this is concerning. We need to figure out, first, this is concerning, but still we can say something about what fraction of these results that are available are no. Okay, so among what's available, what fractions are no? Think of how much you think that we would find, right? This is the distribution. A lot of null results. This is surprising for us. This was surprising for us. On average, 64% of the study of the results that are available are no. And again, this goes against the grain of the idea that a key component in these simulations by Ioannidis was that you have a lot of buried nulls. At least in this field, at least in this methodology, it seems to be that a lot of what's reported out there is no. This was surprising for us. Is it surprising for the community? We asked forecasters. We said, like, what do you think is the average fraction available? Among what's available, what do you think is the average fraction no? Here in blue, I'm showing you the distribution of the answers of 68 forecasters from the social science prediction platform, mostly econ professors and graduate students in economics. We see that their average prediction is about 29% or something like that. So they are more pessimistic. They think that we're going to find less. We found 48%. So that's the first finding. And in terms of no, they think that we're going to find almost nothing, that less than half is going to be no, and we find that 64% it's no. Okay, so not only surprising to us, it seems to be surprising for the community too. So in terms of the contributions, where are we? We have learned that the size of the file drawer measured in the ways that I'm presenting it today is about 58%. And the conditional availability, the fraction of no, is 64%. That's what I've shown so far. Now we're going to try to understand, okay, what prevents researchers from reporting missing pre-register results, pre-register hypotheses. And we're going to test these constraints. So for that, we're going to take this amazing data set, and we ran a randomized controlled trial where at the study level, we sent emails to authors of these studies where we sent three times of interventions, encourage them to report what happens with the pre-register hypothesis, and then 6 months after, we repeat this process of collecting what's available and see what can be recovered. Okay? So what are the main constraints preventing researchers? We hypothesize that one constraint could be sort of like lack of awareness. Maybe people are not so used to the idea that they need to report on everything that they register. So that could be an idea that it's behind the lack of reporting. Another one could be like researchers might think that the research is not valued by the community or not looked by the community, and this is a constraint I'm going to call engagement for abbreviation in the slides, but it's engagement plus time, because also it could be that they lack engagement they have low perceived engagement with the community, but also don't have the time to report on what's going on with their previous studies. That could be another constraint. Another constraint could be that they're short on resources. They don't have the arrays. They don't have their own time to carry out these, to report on what happened with registered studies. So we're going to test these 3 constraints. How we're going to do it? We carried out our own randomized control trial, where here I have the interventions. And we implemented over 4 arms, a control arm that didn't receive anything. Everybody received an email saying that reporting all results is useful for the scientific community, and we encourage you to report your own results. In addition to that, we provided a standardized empty results report. This is among this other contribution I was mentioning of providing a structure to report results. The awareness arm received both interventions, and then the engagement and resources arm received incrementally more. The engagement arm received everything that the awareness arm received, plus a pre-filled results report. We took the results report and we populated with how we encoded their study. And on top of that, the resources arm, we gave them the pre-filled results report, and on top of that, we told them, we're offering you up to 30 hours of Berkeley arrays, or $1,500 for you to find do the work to pay your own arrays to find these missing results. I really like our results reports. I think that's an important contribution, and linked to the conversation, the keynote presentation in the morning around reporting guidelines for medicine and public health. This is a field in medicine and public health. In economics, it's just starting. And I think one important insight that our team has had is to not push for tell the economics profession how to write their papers, but to build something like a standardized appendix that they can put into their studies. So we send something like this. We send them a template that is 1 sheet per hypothesis. And in this case, I'm showing you the pre-filled template for the awareness arm. So in this case, it's a found hypothesis. There's a lot of details in here that, again, I'm going to skip, but I love those details. And then here's our statement of the hypothesis. We ask them to say, do you think this is correct? We also show them the results. Do you think this is correct? And we also show them the heterogeneity test. Same questions. Okay? Did the authors engage with our intervention? Did they pay attention to what we did? Okay? We sent all these emails. We did all this effort. Did people do something with it? The answer is yes. For all arms, we check how much they click on what we send on the emails. 90% of authors responded to click on something inside of the email. So that tells us that they read it. About 80% click on the results report. There's an important difference for these 2 last arms where we got a lot of informative responses through emails in response to our intervention. Okay? This is not telling us whether or not we regard the hypothesis, but it is clearly showing that there's a strong response to our intervention. This is the result for our for our pre-register specification on the effects of fraction available. Here, what I'm showing you is the effects of the 3 arms. And we see, A, that awareness does nothing in terms of increasing availability. B, that both resources and engagement increase availability in around 6 to 7 percentage points. And C, there's not much difference. There's essentially no statistical difference between engagement and resources. So $1,500, 30 hours, doesn't matter. Okay? At least in terms of availability. Given this, we also specified this in our pre-analysis, that if we found this, we're going to pull these 2 arms and say that this is like the strong encouragement arm. We're going to pull this, and now I'm going to show you results only for the pulled version of engagement and resources. All right? I'm not going to show you the entire regression table. We can review in detail, but the main estimates is that if you pull for availability, you get around 6 percentage points. If you pull in terms of null, you get around 4 percentage points. And in terms of explain, you get around 9 percentage points. Additionally, also for Awareness has a somewhat smaller effect on explain, but it is something that we recovered around 4 percentage points of the missing hypothesis through an explanation. So that's and another important part is that even though this is a positive and statistically significant effect, it is a construct. The effect on null, it is a construct of recovering more results. When we look at the distribution of the newly recovered results, we see how they are distributed in terms of across arms. Basically, the distribution of null, it's essentially the same as the distribution of nulls in the originally available study. So this is not that we're recovering a bunch of nulls. We're recovering basically results that look pretty similar to the results that we already had. Okay. In terms of the types of explanations that we receive written explanations that we categorize into different forms. Here I'm accumulating the explanations, and let's focus on this column, and the column for estimate. That the first explanation that we hear something along the lines, we never carried out the intervention, or we never implemented that arm. So there's nothing to say about that. We carried out the intervention, but we didn't collect the follow-up data. That's another explanation. Then there are other more subjective explanations along the lines of, we carried out the intervention, the data is bad, we have the data, but we haven't done the analysis. We have the data, we have done the analysis, but there's low power, and there's a disagreement with how we encode things. The estimate of 9 percentage points that I'm showing you only includes these two stringent categories of an explanation. These other four, we could include them, and we would be explaining about 14 percentage points of the file drawer. But conservatively, we go with this 9 percentage point estimate. So putting it all together, our second main finding, in terms of understanding what is behind missing results in pre-registered RCTs in economics, this is again, my favorite figure that I showed you at the beginning, a little bit cleaner, and just put the size of the file drawer up there for the entire sample. Now I'm going to show you the same figure, but only for the awareness arm, T1, the first intervention. So this is the same figure before the intervention. Just because of some random variation, the file drawer is of 57%. We carried out the intervention. How much do we recover? In green here, I'm showing you the newly available, and in blue, I'm showing you the newly explained hypothesis. So this is the 4 percentage points that we recovered through newly explained. The availables, I'm not including them here because they're essentially 0. Now I'm going to do the same exercise, but with a strong intervention arm. So I'm not going to show you the awareness group. I'm going to show you the group that has the encouragement or the resources. This is the baseline. Before our intervention, the size of the file drawer was 57%. We carried out an intervention. What do we recover? A fair amount, right? So the green bars are going to represent 6 percentage points of the size of the file drawer, or 10% of the file drawer. The blue lines are going to represent the 9 percentage points, or 16%. If you put all that together, basically we account for about between a quarter and a third of the size of the file drawer. So we think that this is pretty informative. Again, going back to our summary, this was our first contribution. This is our second contribution. We learned that in terms of the binding constraints, awareness doesn't seem to be the main constraints here. It does seem to play a role for a little bit of a role for explaining missing hypotheses, but nothing for increasing availability. Engagement or engagement plus times seem to be the key binding constraint here. And importantly, additional resources doesn't seem to play a role. So that's also informative. Direct policy recommendation for us is do not subsidize additional array time to do this type of things, because it doesn't, on top of what goes into engagement, there's not much of a role. And if you put all that together, we account for 28% of the file drawer. That's pretty much it. I wanted to say thank you very much for my amazing team. This was a privilege of a lifetime, and there are the slides, and happy to take any questions.
Hi, thanks for that presentation. I'm in health, so I do not use your AEA registry, but in clinical trials, we get reminder messages that say, you have not reported your results, and they keep coming until you enter something. Yeah. But does your registry not have that? It seems like a simple next step of like automated, because you have to say, when will your final data collection be? And then when will you report your results? And then, if a year goes by, it just keeps pinging you like, hello, where are your results? Yeah, the AEA registry is testing something like that. They just roll out their own randomized control trial to see whether or not this type of reminder makes a difference. And their ask is very low. They say, like, can you please give me a link in the post-registration results? Put a link in there, nothing else, and the effects are minimal, essentially. There's very, very low take-up out of that. But health also has some issues in the sense that you're not only asked to be, in some sections, some fields of health, you're not only asked to get reminders, but you also supposedly have to pay a high penalty if you don't report results. And there's research showing that even with these gigantic penalties, people don't report the results anyway.
The penalties have never been collected.
Exactly, yeah.
Collected by the American government.
Yeah.
But interesting, we do have in health also that 50% of the clinical trials also have negative results. So that result is sort of the same. That's great. Yeah. Often don't work compared to the gold standard or most things. But I was curious about in health, you're more likely to have just one hypothesis, or maybe 2 or 3 if you're thinking 2 years, 5 years down the line of what the effect of the drug is.
Yeah.
Here there seems to be a 10 hypothesis per trial.
Yeah.
For all of those that have started, does that mean that they were able to complete all 10, or do different branches start at different time? Because you said 20% of trials have never started, but for the rest that didn't report things, some of them didn't report some of their hypotheses. Yeah. But in theory, when a trial is done, could they have calculated results for the hypothesis, or were some parts of the hypothesis not done even though the trial is done?
Yeah, so for the ones in blue, we know why they didn't report. But for everything that's in white, we don't know whether or not they finish it. We don't know. Those are unknown missing hypotheses. And the other, I forgot what was the other question. Sorry. Yeah. Yeah. So, for example, this study, take this study here. This could have been a study that carried out this section and dropped those arms. So this is something that we do know. The white section we don't know.
How does not to sound, but how does then the registration work if you can drop the trial? You can drop arms of it.
Baby steps. First you start asking for a registration, and then you start making things more accountable. Yes?
So you said that you were actually surprised at how many null results you found.
Yeah.
But because of this issue of having like 10 hypotheses per study, were you more likely to find the null results being reported in studies that had a positive result to report? Like people could stuff, oh yeah, I got a bunch of null results, but I got this really exciting positive one that I could put in the paper, and were they more likely to actually publish?
Yeah, we haven't tested for that. I think we can think of ways to test for that, but that's a good idea. Thank you.
Thanks for this interesting paper. So I have a similar question. So the power calculations at the beginning, are they doing those power calculations for all the hypotheses or just for like one? And then if they aren't doing the power calculations for that question at the end where they had the response of, no, we didn't have enough power, is that a valid response, or are they just saying, no, we had a null result?
Yeah. So that's why we put it at the very bottom as subjective, because power is something I should be able to address before you look at the data. So like saying an answer along the lines of, we did the analysis, but there's not enough power. It's a very common answer, by the way, but it's not a valid one. It's just that where is it? So yeah, 10% of studies, 19% of the hypotheses, of the ones that are explained, say we don't have enough power. But that's something that, no, you should have said at the beginning. Yeah. Please.
Thank you so much, and congratulations to the whole team on this. It's really exciting. I'm curious I'm sure you've thought about this, but I guess what you're thinking in terms of implementing this in the real world. Obviously, This is the RCT, and the results are really informative, but how would you think of scaling this?
Yes.
And are there any plans to do so?
So action item A, right away, we can work with the AEA registry such that they send the empty results report for people to report on their studies. We should not expect an effect on availability, but we should expect at least an effect on learning about some missing studies that we learn about an explanation. That's one. B, this is where stage 2 comes in, that if we want to do this exercise at a high scale and provide this pre-filled results report, the cost per array, it is a little bit less expensive than the 15 hours. We got it at 10 hours because we were not focusing on the entire paper, but still, it's not feasible to do it at 10,000 papers or something like that. So this is where we're exploring whether or not bringing an LLM that provides sort of like a first draft of a results report that provides it to the authors to say, hey, do we get it right, wrong? Can you fix things around? Given that we're giving you the results report, maybe you know better how to modify it. So that's the next step in this research agenda. Yeah. Okay.
Clinical trials have built, independent researchers have built what we call trial trackers that sort of publicly state which universities have how many trials and which have those that are reported. But they have also implemented what they call report cards based on those that the researcher gets, how you could then put the results in that sort of increased. And we've seen when those went to newspapers in Germany and the United States, that increased the results reporting much more than direct contact, because the visibility of the universities and their reputation seems to be a little bit stronger than on individual level.
Yeah, definitely more to explore. Thank you.